All right, sweet. Well, let's just go ahead and start this thing.
Okay.
So question 2, given a 90% confidence interval of 45 to 105 for a mean heart rate, which of the following is the best interpretation of this confidence interval? And I said we are 90% confident that the true mean heart rate is between 45 and 105.
That's what I got as well.
Yeah, that's what I got.
Cool. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go or no-go stimulus of males differ from that of females. The researchers randomly select 20 females and 15 males to participate. The go, no-go stimulus require the student to respond to the particular stimulus and do not respond to the other stimuli. The researchers decided to construct a confidence interval to determine if the confidence of the mean is significant. To determine whether the confidence interval would be reliable, they create a QQ plot to both random samples and see that they are approximately normal. Are the requirements constructing confidence interval satisfied? Why or why not? I put yes. The distribution of the mean of each sample is normal since the data have been determined to be normal. So the third one.
Works for me. And number 4, of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? And I went with number 3, confidence interval for the difference of means, independent samples.
That's what I got as well.
So how did you come up with that or come to that decision?
Because let's see,
Excuse me.
there's 20 females and 15 males, but they're not directly connected to one male and one female. And so we're totaling all of those and getting a difference of the means, not a difference of the I can't tell you how I can explain. I mean, I don't know.
So because they're independent samples, the male and female, then
They're not correlated.
and standard deviation wouldn't even apply then. Is that correct?
Correct, because they're not paired.
Okay.
Right.
So that's where I have trouble is when mu and standard deviation, whether it applied or not. And if they're independent, that would, I mean, difference of means, I guess that makes sense why those wouldn't be, or they would not really apply to Y or a choice.
I'm not very good at explaining it, but that's was my internal logic.
Okay.
And there are a couple of those choices that don't even fit the situation.
Yeah.
Right.
That's how I came up with it. Like, they're not paired, so they have nothing to do with each other. And you want to find the differences, and they're totally independent from each other. If it was saying it was a married couple, that would be a different situation, but it was just kind of random.
Okay.
So,
and one of the examples we're going to do later on is comparing airline flights, and we're comparing a 90-day price to a 14-day price. Some of those, they didn't have a 14-day price, so you threw out the 90-day price too. So that's a paired. But in this case, there is no correlation between one and the other than the totals. Does that make sense? I mean,
Yeah.
Is that accurate, Blake?
yep. That's what I got.
Number 5.
Yes, sir.
A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains a savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of the bank customer is found to be $3,402.08 and $4,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? Would that be B?
It's not what I got.
So if you want to narrow the margin of a confidence interval, you want to increase the number of samplings that you're taking.
So D.
It'd be D.
Okay.
Yep.
Okay, a factory makes propeller drive shafts for ships. The quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds that their sample mean to be 1,000 millimeters. Lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. Input your answer for the margin of error below, or the margin of error, lower bounds, and upper bounds. So for margin of error, I did 1.96 times 2 over the square root of 4, and it comes out to be 1.96.
Mm-hmm. And 1.96 is just the 95% confidence interval, right?
Yes, that is the 1.96 is the margin of error. So from where the mean is at 1.96 up and above or below is where you're going to get your 95% of your answers.
And then did you put that into the applet as well?
No.
No. Are you? And what was the what's it called formula you used?
I did the Z asterisk or the confidence interval, 95%, which is the 1.96. And I times that by the standard deviation divided by the square root of sampling means, or number of samples. So it was 1.96 times 2 over the square root of 4, which is 2. So it ended up being 2 over 2, which is 1. So 1.96
Okay.
is 1.
Makes sense.
And then just for lower bounds, subtracted 1,000 minus 1.96, and that should give you 99904. 99904.
99804.
99804.
Yeah, 804 is what I got.
Yep.
And then upper 1001.96.
Correct. Going back to number 5, so it's increased the sample size to 90. That was the answer?
Yes.
Yeah.
Okay. Number 9, to assess the accuracy of a laboratory scale, standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the means of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean mu and a standard deviation of 0.01 grams. How large should the sample size be so that in a 95% interval, confidence interval for mu has a margin of error of plus or minus 0.0001? And I got 38,416.
Yep. So I got it as well. And how'd you compute that again? Just want to make sure that I'm doing it correctly too. I got the right answer, but
to be honest, I put the numbers in a spreadsheet.
okay, cool.
So if you want the equation for it, it's the n, or number of samplings, is equal to, and then in parentheses, so I'll just write it big.
It's critical value z times.
Okay,
So
oh,
right
well
there,
done.
that, so this is it's n equals standard deviation times z asterisk over the margin of error, and that's all squared. That's the equation. If you take the margin of error equation and then solve for n, that's what it comes out to.
So is that the MZ one?
Yeah,
Or is
so
that-
that's m equals z times standard deviation over root n. If you solve for n, it comes out to that, so the n equals z times standard deviation over m all squared. That's how I computed the 38,416.
Okay, cool. I think it's me, right?
Yeah.
All right, cool. All right, the mean area mu of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure the random sample of apartments and test the suspicion. The appropriate null alternative hypothesis, HO and HA for mu are, I got the last one, to equal to 1,250 and is greater, or is it less than 250, because I got that because they thought it was going to be smaller. So that's what they're trying to look at. That's how I got that. Like, that's their hypothesis, is they think it's smaller. So that's one.
Looks good.
That's how I got it.
So my turn.
Yep.
In a statistical test of hypothesis, we say we reject the null hypothesis with the level of significance if the p-value is less than.
Yep.
Would be.
That's what I got.
Must be my turn again. A group of statistics students wants to determine if students in some apartment buildings are getting better grades than students in other apartment buildings. They collect GPAs from anonymous random samples, size 15, from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use the ANOVA hypothesis test to answer their question? And I said, yes. There's enough data for each apartment building. And anyway, the third one is what I went with.
That's what I did as well.
How does, I mean, I think I understood that, but there's one point in the introduction to ANOVA that it's saying it's always right skewed. And how does that relate to the bell-shaped distribution?
Because it's 15. If it's anything more than 15 to 30, that's where usually comes like a tail with it, right or left. But it says it's 15, so that would be a bell curve.
Okay.
Because that's like the minimum for like the most you want is 15. Anything over that, you'll see a tail. Even with 30, you can see left or right skewed.
Okay.
Okay, a medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that the average survival time after diagnosis is the same as the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The research has committed a type 1 error, incorrectly used the 0.05 significant test when it was used to compute the p-value, incorrectly used the 0.05 significance level when it should have been used as a 0.01 significance level, committed a type 2 error. So for this one, it kind of confused me. I don't know which one it was, but I feel like after reading it again, I mean, it's 1 or 2 type error, and I was kind of assuming it'd be a type 1 error that they committed.
That's what I did. That's what I assumed.
Yes.
Okay, sweet. And because the next question kind of follows up with it, so.
Yep. There's a lot of them like that. If you get the first one wrong, you're going to get all the other ones wrong too.
Yeah.
That's what I don't like, but it happens. So if the level of significance alpha is made very small, thereby making probability committing type 1 error very small, what happens to the probability of committing type 2 error? It's the first one. It's by reducing the probability of committing a type 1 error, we increase the probability of committing the type 2 error.
Looks good.
That was the only one that kind of like made sense, especially with the first one. So
Yeah. Did we lose James?
I think
Yeah,
we
I
did.
think so.
Oh, I didn't realize he was gone. Okay, my turn then. Number 15, the nicotine content in cigarettes of a certain brand is normally distributed with a mean of mu and a known standard deviation of sigma equals 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of X bar equals 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. And I said, actually, I already did this when I got it wrong. So it has to be, we reject the HO, which means they're not higher than they advertise it is.
Correct.
But because I got it wrong, I don't know what I did wrong first time yet.
So for this one, I solved for the z-score. So I did the x bar minus mu, which was the 1.53 minus 1.5. and I divided by the standard deviation over the square root of 100. So that gives you 1.765. I plugged that into the probability applet, which gave a probability because you just want the left side of the curve, and it gives you like 0.030 something, and so it was less than the level of significance, and so that's how I came to choose rejecting the null hypothesis.
Well, that makes sense. I didn't put it into the output. I had the right p-value, and I was thinking reject p. I was taking it to that, and I didn't go on to the applet.
Okay. Okay, number 16 says you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like to do a random sampling of 100 for each group and test if those means are different. What is the correct statistical procedure? So I got this one wrong. I thought it was because you were looking at differences, it was a paired sample t-test. But I mean, would it be an independent sample t-test instead? Because they are independent of each other?
Yep.
Yeah.
They're not married.
Yeah, okay.
Because
That's where my
female.
thinking earlier is that's hard. It was hard for me to understand.
I hate these ones, but you have to really read the question because, you know, if they said a paired sample, like married students, then that would be a paired test. But it's male students and female students, like they have no correlation. So,
Right.
Yep. I have to read those things like 4 times just to make sure I'm like, all right, is this what it is?
Well, in
Yeah,
contrast, if you
go for it,
contrast
Lester.
that to number 17,
Mm-hmm.
it's talking about brothers and sisters, and that are next to each other in sibling order. An educator is interested in the academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother and sister pairs when they are next to each other in sibling order. So they've really told you that these are paired samples or dependent samples.
And they're related, so yeah. So that's be dependent. Yep.
Yeah, so that's kind of a contrast to the previous one with they're just girls and boys.
Okay. But how would you choose between the two dependent samplings, like which one actually gets across the fact that they are dependent samplings?
Because it says on the last one, that's what I got for the answer, because it says dependent sampling, you have to select the brother as to compare his academic achievement to a sister, and you must include the sister in your study. Because if you didn't do it in the study, then that would be independent, because that would be just the brother, not the sister.
Okay.
Because on the other dependent sampling, this is sister academic achievement depends on some degree on brother's academic achievement. That doesn't state that they're inside of the study.
Gotcha.
So that's why it was the other one, because it says it mentioned that's inside the study, so they're dependent. If it was just a sister, it would have been independent just on sisters, not dependent because relation.
Okay.
That's how I thought of it.
Right. No, that makes sense.
I can do 18. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? And I went with the first one, confidence interval for mu when sigma is unknown.
That I got as well.
And so how do you determine if sigma is unknown? Is that just because it's not given, even though the applet solves for it, so it's considered still unknown, or? Because that's where I struggled with this one, because I mean, if you use the applet, technically you know the mean in sigma. But I guess because it doesn't, yeah, it doesn't make sense to me.
Well, you know if it's the first two, not all four. Because you're doing a paired, right?
With the dissolved organic carbon, it's just one set of numbers.
But the way I chose the one I did is because you got a field full of dirt. You're never going to know the sigma. I mean, that's one of those that you know.
It's an anomaly.
Samples, but you're going to never know what the actual mean is in that in that field of dirt. Does that make sense?
A little. I mean, I guess so. I mean, you can find out what the sampling is, or the sampling numbers of it, but you'll never know the actual of the entire population.
That's the way I chose the one I did.
Okay. Okay, for number 19, the margin of error for the 95% confidence interval, I got 2.025.
Yep.
Do you mind walking through that, because I couldn't seem to make that one work. The margin of error throws me, and I can't seem to.
Yeah, so when I solved for the margin of error using the equation, I got 1.895. And then I did what I did, it ended up doing to get the margin of error, especially when it's like when we plug it into the applet. I take the confidence, the lower bound interval, I take the mean minus the lower bound interval, and the upper bound interval minus the mean, and they give me the same answer, and that's always the margin of error.
Okay, well, I guess this is the same thing. I had the 1.896. I just, for some reason, I can't remember that that's got to go into the applet. So.
Yeah, and I solved for the 1.896, but I thought I'd check it using the one sample t-test in the applet, and it came out to the 2.025. So I just figured the applet was right, because I couldn't get 2.025 from solving with the equation.
Yeah, because I got that one wrong because I was doing it by hand and I got it wrong. So it makes more sense though.
Yeah, I don't know how.
So.
I mean, let's see here. Let me see if I can 4.26.
And then for the lower bound and upper bound, you just had to put everything inside the applet. And I got 11.168 for the lower and then 15.217 for the upper.
And I got those right. I just didn't get the, okay.
I did not even think about just minusing the mean from both to figure it out. I never even thought of that.
Because, yeah, your mean is the middle, and then your margin of error is plus or minus the mean, or the x bar, which is mean. So
yeah, never even thought of that.
That's how I've always solved for it when the equation doesn't work.
Okay, good to know.
Okay, so question 22. We want to know if there's a difference in mean listing prices between Hummers for sale in Los Angeles and Hummers for sale in New York. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. So with this one, is it a confidence interval for difference of means, not mean of differences, correct?
Difference of means using independent samples. Yep.
Right. Because they're from two different locations. I figure that's what considers them as independent samples instead of
Even though they're all Hummers, but they're two different cities, two different styles, and parts of the country.
So for this one, did you put it in the 2-sample t-test, or it would be going to the 2-sample t-test or the ANOVA?
Pretty sure it'd be different ones, paired.
The which ones?
The paired sample t-test, or no, it'd be a paired sample t-test. Yeah.
Okay.
Pretty sure.
So why is it paired sample t-test even though they're independent of each other?
Let me try it real quick. I just want to make sure I did.
Because I got all the numbers in this one wrong. Because I think I did paired sample t-test. Let me try them again. Because I thought I did paired sample t-test and it came out wrong.
Did you get negative 423.158?
Let me look. No. Is that the answer?
Yep.
So I got negative 649.
Yeah.
Well, I got.
Let me.
Mine was close to Blake's, but slightly different. Mine was 0.238, and it said I got it right. So
I think they give a little bit of buffer on this one too.
Yeah.
So there's the Hummer. Oh wait, no, I did that wrong. Oops. Okay. Delete. Let me try this one more times. Los Angeles. There were more Los Angeles Hummers than New York, correct?
I think so.
I'm gonna double check this one.
So let's see here. Yeah, mine comes out to confidence interval negative 649 and 7279.
I put mine in the 2-sample t-test for means.
Okay. Let me try that one.
Oh, whoops, I got all of that's.
Okay, so when I put it in the 2-sample t-test, it comes out to negative 423.238 and 5417. And those are correct?
Yeah.
Yeah, 5417 point. I got 0.256 as well. Yeah.
And mine came out to 0.336. That won't matter.
Should be okay.
Because I got 338 and mine and it accepted it.
Okay. So because they're independent, it should be done in the 2-sample t-test, not the paired sample t-test. Paired sample is when they're dependent upon each other.
Correct?
Yeah.
Okay.
Alrighty. Use the following information for the next 4 questions. Many studies have suggested that the length of exercise and healthy bones exercise stresses the bones and it causes them to get stronger. One study examined the effect of jumping on bone density of growing rats. There were 3 groups. Rats were selected at random for the 3 groups. A control with no jumping, a low jump group. The jump height was 30 centimeters and a high jump group 60 centimeters. After 8 weeks to 10 jumps per day, 5 days per week, the bone density of the rats expressed in mg /centimeter 3 was measured. Data recorded there. Researchers would like to determine the mean levels of the bone density are different between the 3 different groups of rats listed above. Use alpha a 0.05 level significant. What is the correct hypothesis test for the situation? It is an ANOVA.
That's what I got.
Is when you've got more than 2 groups, could it ever be anything but the ANOVA?
Not that we've learned.
Okay.
Not that we learned so far. Yeah. I always know it's ANOVA if it's more than 1 group, because that's the only one that we'll actually ever know in business statistics in this class. So.
Okay. 26, calculate the test statistic. And I say F equals 7.978.
Yep.
That's what I got.
Put all those inside of the applet, and I'll tell you all the rest.
Yeah, and for p-value, I got 0.002.
That's what I got as well. Which of the following best expresses the conclusion of the test? Use level significance alpha equals 0.05. There is significant evidence to conclude that the mean bone density at least one of the groups is different from the bone density at least one of the other groups. So number, or four. Yep.
Yeah.
Okay, use the following info for the next 4 questions. Pressures of supply and demand act directly on the prices of airline ticket. As the seats available on the plane begin to fill, airline raises the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of the airline ticket purchased 90 days in advance of the scheduled flight compared with a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from Heathrow to a variety of destinations in Europe. The lowest published ticket prices for one-way flights from Heathrow to various destinations in Europe was recorded for each of the scheduled flight 90 days in advance, and then again 14 days in advance. Perform a hypothesis test to determine if there is a difference in the mean cost of nonstop flights when tickets are purchased 14 days in advance compared to 90 days. Level of significance, alpha equals 0.1 for the next 4 questions. Okay. So 29, what is the correct hypothesis test for this situation? And it's definitely dependent.
One air
so
flight.
That's the one we've got.
What I got as well. Dependent sample test. So nonstop flights wasn't said.
So for this one, we'd then be using the paired sample t-test because they are dependent upon each other.
Yeah, it says that 2 or 3. I mean, at least once it says. It compares. I mean, the way it's worded, it's pretty obvious that it's linking together.
Right. The first flight their second flight depends upon the first flight.
Yep.
Yeah.
So with that, would the t-value be 1.685?
Yep.
That's what I have.
Okay.
And then p-value, I got 0.096. Cool. No, actually the last one. Which of the following best expresses the conclusion of this test? Use the level significance alpha 0.10. There is sufficient evidence to conclude that there is a difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance. So the second one.
Okay.
Because the question 31, it's higher than level of significance, or lower, correct? Is it lower?
If it's lower than the level of significance, we reject the null hypothesis, which causes there to be enough evidence.
Sufficient, yep.
Sufficient evidence, yeah.
Cool. Oh, look, it's time to submit it.
Let's get better than what I got last time.
30 out of 30, guys. Woo! Sweet, guys. Well, good luck on the test. I think it closes on Saturday, right?
Yeah, at 11 p.m.
11 p.m. So I know what I'm going to be doing on Saturday. Hopefully on Friday, but
Yeah. Okay, well, good luck, and you guys have a good weekend.
all right, you guys do the same. See you later. Good luck.
I got one question.
Yeah. What's
Oh,
up?
yeah.
The previous test said you could use 1 page of notes.
Yeah.
Did this test offer that? I haven't seen any instructions yet.
I haven't seen any. I just used 1 page.
Yeah, I would assume it's the same. I think it said that in the syllabus.
Mm-hmm.
Oh, okay. Well, good. I'm hoping. I'm kind of counting on it.
Yeah.
Working on my fine print.
Yeah. All right, guys.
Thanks.
I'll
See you.
see you guys later. Peace.